So today we're going to do 1.2 and 1.3, which is going to talk about transformations of absolute value functions. Okay, so an absolute value function is just an equation or a function, bless you, that has absolute value in it. Okay, what is absolute value? Okay, absolute value is technically the distance a number is from 0 on a number line. Okay, we are going to do the graphs first today, and then Friday we're going to do absolute value equations and inequalities. Okay, so this is just transformations. We're going to do graphically. Next class we'll do everything algebraically. Okay, so an absolute value function is actually very similar to a quadratic. Okay, so if we think back to quadratics, do you remember what that would look like? Okay, do you remember what a parabola looks like? I don't think y'all do that in geometry, so I'm not sure. So if I had an XY axis, a parabola is that U-shaped graph. Y'all remember that? Okay, and it was always y equals x squared. You had an x squared in it. Okay, linear is y equals mx plus b, and then quadratic is your x squared. Okay, so absolute value functions are extremely similar to a quadratic. Okay, with quadratics you learned there was a vertex. Y'all remember that name? Maybe, hopefully, that term. Your vertex was the center of your graph because the parabola was symmetric. So you had a vertex in the center and everything else was symmetric around that, okay? So it's going to be like the same exact thing, but absolute value instead of a U is going to be a V, okay? So I'm bringing this up because they're so similar, okay? So the parent function of absolute value functions is f of x, which is the same as y. F of x equals your absolute value bars of x. Okay, so those bars are absolute value. So absolute value of x. So you're going to need to know your parent function. Anything other than the absolute value of x is a transformation. Okay, so we're going to talk about how to build the table and how to graph it. You're going to do the table and the graph for the parent function for every single problem, so I promise you, you will have it down. Okay. We're not going to use the Inspire graphing calculator because it can give everything to you. You need to know how do I build a table with this transformation that we're going to do. Okay, so we're going to start with absolute value. Okay, I'm going to tell you right now your vertex is at the origin, just like the parent function for a quadratic is at the origin. So the vertex is at 0, 0. So when we build our table for absolute value, I'm going to do 2 points above and 2 points below. Okay, so I'm going to use the x values, -1, -2, +1, +2. Okay, so how do we get those y values if I'm not getting a table from a graph? All you're doing is plugging in these x values for your function. Okay, so the absolute value of -2 is what? 2. Okay, absolute value is always positive because you're talking about distance. Okay, so when I have -2 for x, my y is 2. If I took the absolute value of -1, what would that be? 1. Absolute value of 0 is 0. Absolute value of 1 is 1. And the absolute value of 2 is 2. Okay? Y'all follow how I got these y values? You will have them memorized probably by like the third or second example. Okay? Do you recognize anything with this table? So around this vertex, my y values mirror each other because your absolute value function will be symmetric for the graph. It's a V. Okay? So when we go to graph it, I've got -2, 2, so I'm going to go -2 on my x and then up to 2 for my y. And then -1, 1, 0, 0, 1, 1, 2, 2. Okay? When you do graphs in here, do not make a graph short. Okay? So you're going to extend all of your graphs a decent amount, okay? Also, it's a continuous function. If you don't put the arrows, I will count off, okay? So, make sure you have arrows, make sure you extend it. That is what your parent function of an absolute value function looks like, okay? Do we have questions on that? All right. So again, it just iterates that for y equals the absolute value of x, the vertex is at 0, 0. Okay? But now we're going to look at vertex form. Okay, vertex form is going to be key in everything we look at for this particular lesson, and that's going to tell us our transformations. Okay? So, I have y equals a, my absolute value of x minus h, plus k. Okay? When you did quadratics, the quadratic vertex form is y equals a parentheses x minus h quadratic catus square plus k. Alright, so I'm bringing this up because they're the exact same thing. Okay? Quadratics and absolute values are so similar in everything you do. So, with the vertex form, your vertex is hk. And you will learn this whole year, vertex is always hk from vertex form. Okay? Now, if you look at what's happening in your formula, h has a minus already in it for the formula. Okay? So when you're looking at your equation, it is the opposite sign of what is already there. Okay? K is as is, that's the y value of your vertex. The x value of your vertex, h, is just the opposite of. You're going to learn every single time we do a transformation, x is always the opposite of what it looks like. Okay? Alright, so let's look at what transformations are. Okay, your transformations, you can have a translation, which means you shift up, down, left, or right, or you can have a vertical stretch or shrink. Okay, so we're going to look at each thing. Your parent function is always going to be in these graphs. Okay, so your parent function is that middle graph. And if I compare that to this equation, absolute value of x plus 2, what happened there? From this parent function that's in the middle to this graph of absolute value of x plus 2, what happened? It went up 2. It went up 2 units. Okay, if I then compare my parent function to the lower function, that's the absolute value of x minus 2. What happened there? It went down 2 units. So what do you think is causing that direction up and down? What is different from my parent function equation to this one right here that made it go up 2? The 2. Okay, here it was a plus 2 and I went up. Here it was a minus 2 and I went down. Okay, so if you have a plus k tacked on, any number tacked on behind those absolute value bars, that's going to shift it up or down because that's affecting your y of your vertex. Okay, your y-axis is vertical, it only goes up and down. So if you have something added on, you're either going up if it's positive or you're going down if it's negative. Okay, so because you're going up and down, your new vertex would be 0k. I didn't shift left and right, so it doesn't affect my x value of my vertex. I only shifted up or down. Okay? So now if you look at the next set of transformations, I've got my parent function again in the middle, going through the origin. And then if I look at this right one, I've got the absolute value of x minus 2 inside the absolute value bars. Okay, but where did it said a minus 2, but where did it go? It went right to. And if I look at my parent function compared to the absolute value of x plus 3, where did that function go? What happened to my graph? I went left 3 units. So I just said in the page before this, anything that's with your x inside your bars is the opposite sign, right? The x value is the opposite sign. So the same thing happens with your transformations. So if you have something added or subtracted inside the bars with x, then that's going to shift it left or right. If it's positive, it's going left. If it's negative, it's going right. You have to be careful with what's going on with your x. I always say x is a liar, so that helps me know it's the opposite of. Whatever it says on my paper, it's lying, it's the opposite of. Okay? So then your vertex, would that change my x value or my y value? If it was going left and right, it would change my x. So my vertex would be H0. My y wouldn't change. Good so far? So now, if I have my parent function going through the origin again, and then I look at 2 times the absolute value of x, what happened to that graph? So vertically, it looks like it's just getting stretched, which horizontally makes it skinnier. Okay, so here, it's getting skinnier, more narrow, whatever you want to see it as. Okay. If I compare that to this negative 1/2 times x, width-wise, what happened? It got skinnier or wider? Wider. And then what else also happened? It changed directions. Okay, so I'm going to talk about changing directions in a minute. So what's going to happen if you have a number in front of your absolute value bars that's being multiplied, that is going to tell me I have a stretch, a vertical stretch, or a vertical shrink. Okay? Now, you have to realize this is vertical. So I talked about how it got skinnier or wider, and that's technically horizontal. So if you think about when you were a kid and you played with Play-Doh, okay? You get the Play-Doh out, and the first thing, typically, the first instinct is to do what with that Play-Doh? I always say smush it. That's usually everyone's first instinct. You smush it. So vertically, I'm pushing down on it. What's happening horizontally? It's getting flatter, right? Okay, if I decide I'm going to roll it up and then stretch it, what happens to the width of that? It gets real skinny, right? Can y'all visualize this? No, that's a horrible analogy, but it works, okay? So vertically, if I stretch, it's getting skinnier. Vertically, if I push down, I'm shrinking, it gets wider, okay? So if you have a number that is greater than 1, that's going to give me a stretch. If I have a number between 0 and 1, what type of number is between 0 and 1? Decimals and fractions. Okay, so if I have a fraction less than 1, then that's going to be a vertical shrink or compression. I always write shrink because it's shorter. Okay? Now, the negative, if I have y equals negative absolute value of x, that means it's going to open down, and that is a reflection over the x-axis. That is why y equals negative 1/2 times the absolute value of x, open down, because of the negative. The only thing the negative is good for is to reflect it. It does not indicate a stretch or a shrink. A lot of people get that mixed up. So do not see the negative related to stretch or shrink at all. You're only looking at the number for this. Okay? So don't forget that's going to make it a reflection. All right, so we're going to sum that all up and write it again just so you get it down, because these transformations we're going to use to build our table. Okay, so if A is positive, so the number in front of your absolute value bars, if A is positive, the graph opens up. And it will have a normal looking V. If A is negative, anytime I have a negative in front of those bars, where is it going to open? It opens down. So it says if the absolute value of A is less than 1. All that means is if the number is less than 1. The graph has a vertical shrink. It gets wider. If the value of A is greater than 1, the graph has a vertical stretch. It gets more narrow. Now, what if A is 1? I don't have a number there. Then do I have a stretch or a shrink? No. The graph has the same width as the parent function. We good with that? Okay. So what I'm going to do in the middle right here, I'm going to write that vertex form just because I don't have space at the top to do what I want. So I'm going to have y equals a absolute value of x minus h, close your absolute value, and then plus k. And we're going to write out just right here what each thing does. Okay? If you can get this down, then you should be good on your transformations. Okay? I always try to give you the most important things you need to know. Okay? So this A, the number in front, what does that tell me? What does that affect? It could either be a stretch or a shrink. What does the value of A have to be for it to be a stretch? Greater than 1 or less than 1? Greater. Think about stretch. You're getting bigger, right? So your number needs to be greater than 1. Okay, so if A is greater than 1, it's a stretch. If it's a fraction less than 1, so I'm going to say fraction less than 1. Because some fractions can be greater than 1, so you have to be careful. If it's a fraction less than 1, it's a shrink. Okay? This H, what do I know about that H? If it's inside my absolute value bars with my X, it affects the X. Okay? So it's going to shift it where? Left or right. I'm going to put an L and an R. And remember, it's the opposite of. So left is really if it's a plus. Right is really if it's a minus. X is a liar. And then K, it's happening outside your bars. Anything outside the bars is Y. All right, so that's going to shift it where? Up or down? Up if it's positive, down if it's negative. Usually when I teach it like this, no one really messes up. The only time people mess up is forgetting to flip the sign for your x, okay? Now, if there's a negative, that's a reflection. I'm not throwing that in there, okay? All right, so what we're going to do is we're going to have a function. We're going to do the parent function table and graph the parent function. Then we're going to look at our equation and see how are we going to build this table to get the transformation table to get the transformation graph, okay? So we know parent function is y equals absolute value of x. If you forget, it's right there. Okay? And I said that your vertex was at 0, 0, and we had -2, -1, 0, 1, 2 for my x values. Okay? And then our y values, absolute value of -2 was 2, absolute value of -1 was 1, absolute value of 1 was 1, absolute value of 2 is 2. Okay? Same table for your parent function every single problem. Okay? So then I'm going to graph that. Now this is where I use my second color when I do my transformation. You don't have to, okay? Y'all are just fine to do it with your same pencil, okay? So with my transformation, I look at my equation. Y equals the absolute value of x plus 3. The only thing that changed with this was this plus 3, right? It's inside the bars with the x. So that means my x values are going to change, okay? So x, I said, is a liar. So instead of putting x plus 3 in this header for the table, I'm really doing the opposite, and it's going to be x minus 3. Okay? So anytime you have something added or subtracted with your x, you have to change the sign. Okay? Now, is anything going on outside the bars? No. So my y values stay the same. Okay, so what I'm going to do is I'm going to take all of these x values from my parent function, and I'm going to subtract 3. So -2 minus 3 is -5. -1 minus 3 is -4. 0 minus 3 is -3. 1 minus 3 is -2. 2 minus 3 is -1. We good with that? Okay. Now my y values, I said, didn't change, so I'm going to copy all of those y values. 2, 1, 0, 1, 2. That's my new graph. Okay? So -5, 2. I'm going to plot -4, 1, -3, 0, -2, 1, and -1, 2. Did we understand what I did with that table? Okay. All right, so if 0, 0 is the vertex of my parent function, what is my new vertex? So your vertex is the center of your graph, -3, 0. So the vertex is always the center of your table also. So my vertex is -3, 0. And then I'm going to describe the transformation. So I only had one transformation. What happened to my graph? All right, so it shifts left 3 units. Okay, we good with that? All right. We will do transformations all year long. So if you find it to be pretty simple and you catch on now, it will be easy throughout the year. Okay? Okay, example 2. We're going to start with our parent function. So my x values, -2, -1, 0, 1, 2. My y values, 2, 1, 0, 1, 2. Okay, now, when I do my transformation, I'm going to look at my x. Is anything happening inside the bars with x? No. So x's are going to stay the same. So if you want to go ahead and copy down your -2, -1, 0, 1, 2, you can. Everything on the outside of this x is happening to y. Okay, so this is telling me y equals 1/2 times the absolute value of x plus 2. We know the parent function is really y equals the absolute value of x. So if you replace that absolute value of x with y, because they're equal, then it reads your 1/2 y plus 2. That's how you're going to write your transformation for y. Okay? Now, for transformation tables, I'm okay if you put a decimal, if it ends up being a decimal. Okay? So what I'm going to do is I'm going to take my y value. Am I going to multiply first or add 2 first? Order of operations tells me I would multiply. So what's half of 2? 1 plus 2? Okay, what's half of 1? 0.5 plus 2? 2.5. You could do this in your calculator. We're just going to talk through it. All right, what's half of 0? 0 plus 2, 2. Half of 1, 0.5 plus 2 is my 2.5. Half of 2 is 1 plus 2 is my 3. You should have these mirroring around that vertex still, every single problem. Okay? If not, then check your math. Okay? So then we're going to graph it. That 2.5, hopefully you know how to graph that. That's between 2 and 3. Okay, so what's my vertex? 0, 2. Okay, now how many things happen to my y? 2, right? So I should have 2 transformations. What did this 1/2 affect? It shrunk. So it's a vertical shrink. And then we're going to add by a factor of 1/2. So whatever that value is, that's what you put. So vertical shrink by a factor of 1/2. And then what did the plus 2 do for my graph? It shifts up. 2 units. Always tell me how many units. So direction and how many units. Okay? Y'all good with that? Y'all understand that? Okay. Alright, so we're going to start with our parent function again. You have to have it on every problem. Okay, now, our transformations. Is anything happening inside the bars with x? Yes. I have an x minus 3. What am I going to write for my header for the table? X plus 3. X is a liar. You do the opposite. Okay, so now with y. Anything outside those bars is happening to y. So what am I going to write here? What comes before that y? Negative y minus 2. Okay, so my x values, I'm adding 3. So negative 2 plus 3 is 1. Negative 1 plus 3, 0 plus 3, 1 plus 3, 2 plus 3. Okay. And then negative y minus 2. Alright, so I'm taking 2 and I'm making it negative. So negative 2 minus 2, and then negative 1 minus 2, 0 is 0, 0 minus 2. Okay, then I'm back to negative 1 minus 2, and negative 2 minus 2. Are y'all comfortable how we build this table? Okay. What's my new vertex? Okay, how many transformations did I have? I have 3. Do y'all recognize that? I got the negative, I've got the plus 3, and I got the minus 2. So the negative, what does that negative indicate? A reflection. It opens down. That's all the negative does for me. Okay, so it reflects over the x-axis. That's what makes it go down. Now, this x minus 3 tells me it shifts where? Shifts right 3 units. And where else did it shift? 2 units where? Down. So, and down 2 units. We good with that? Do we have questions? Alright, this is our last graph. So I have my parent function. Okay. What am I going to put for my x header for the table? X plus 1. I have a minus 1 in my equation, so it's the opposite x plus 1. And then everything else is going to my y. So what am I going to write on the y header? Very good. Negative 3 halves y plus 4. Okay, so negative 2 plus 1, negative 1. Negative 1 plus 1, 0. 0 plus 1, 1. Then you get 2. Then you get 3. Okay. Now the negative 3 halves y plus 4. If you want to use your calculator for that, use your calculator for that. Okay? What's negative 3 halves times 2? Okay, I want y'all to fill out the y table. And then we're going to check them. You're going to do negative 3 halves times y plus 4. So when you type it in your calculator, I would do your negative 3 halves and then put your y value in parentheses, plus 4. Okay, get that answer. And I'm going to show y'all an easier way than typing it over and over. So if you just type that in like you should have, hit the up arrow until it highlights that. Okay, press enter. Now you can just change the 2 to a 1. Now 2 and 1/2 is what as a decimal? As a decimal. 2.5. So then change that to 0 to give you 4. Change that to 2. Change that to 1. You have to get comfortable using your calculator. You have to get comfortable using your calculator and finding the values while I do the notes and not just copying what I say. Okay? What's my new vertex? Now, how many transformations did I have? I have 4. Okay, so if I start from the left, what does that negative tell me? It reflects over the x-axis. Okay, then I'm done with that negative. That negative does not tell me anything else. Now I'm just looking at 3 halves. Is the value of 3 halves greater than 1 or less than 1? Greater. So even though it's a fraction, it's still greater than 1, so that should be a vertical stretch. I'm just going to put vertical stretch by 3 halves. I don't have space for by a factor of. Okay, and then where did it shift? that minus 1 was really a plus 1, so it goes right 1 unit. And where else did it go? Up 4 units. Are we good with that? Do we have any questions on the graph? Okay. So now what we're going to do is we're going to use our vertex form and find our new vertex and state the transformations without graphing. Okay? So that y equals a absolute value of x minus h plus k, how I picked that apart, that's what's going to help you here. Okay? So remember your vertex is hk. The number in front tells me stretch or shrink. The number inside the bars tells me I'm going left or right. It's always the opposite of. And then the number on the outside behind it being added or subtracted tells me up or down. And then negative tells me reflex. Okay? So, if I look, I always do my vertex first. Do I have an H? No, so that's 0. And what's my K? -4. Okay? If you have trouble with this, it might help you write your y equals a absolute value of x minus h plus k right above it so you can see vertically it lined up to see what goes where, if you need to do that. Okay? So, with my transformations, I have a negative. That negative tells me it reflects over the x-axis. Then I'm done with it. That 3/4 is the value of 3/4 greater than 1 or smaller than 1. So is that a stretch or a shrink? So vertical shrink by 3/4. And then that -4 at the end told me I went where? Is it happening to x or y? So if nothing is in my x, I'm not going anywhere sideways. So when it's on the outside, that means I shift down 4. Okay. So then my next one, if you need to do your a times x minus h plus k to line it up, you can. For my vertex, what's my h? Okay. It's the opposite of, so it's just 1. Do I have a k? No, so that's 0. Okay, then my transformation. I have a 2. What does that 2 tell me? Okay, vertical stretch. By 2. And then the x minus 1 tells me I'm really going where? Shifts right. 1 unit. Are y'all understanding why, if it happens to x, it goes left and right and not up and down? Because your x-axis is left and right. Okay? Okay, I want you to try number 3. If you can do number 3 on your own, you can do just about any transformation. Okay, what's my new vertex? Positive 3, 2. Okay, what were my transformations? Okay. Did y'all all get a vertical stretch? So be careful if you put a shrink. Just because it's a fraction doesn't mean it's less than 1. And that negative doesn't have anything to do with anything. Okay? After you do the reflection. And then shifts right and okay. Y'all feel good about that? All right.